wabarakatuh. Thank you for Dr. Haziana and Mr. Amin to hear our presentation for our engineering team project. I'm the leader. My name is Muhammad Azri At-Thani bin Nurasi and my teammate is Abdullah Muhammad Hassan, Lee Chang Siang, Nur Aini Syafiqah and Muhammad Fitri. So the presentation will start with introduction with Aini will be presenting it.
Thank you, Muhammad Azri bin Asani. I'm Noraini Shafika. Today I will present my introduction. Firstly, the project building is about administration building, which is administration building have 3 levels: level 1, level 2, and level 3. And this project need to calculate the load in existing design and propose a new appliance to make the existing design use less 5% to 10% of power. This building will design inbuilt final load estimation, like socket outlet, socket outlet arrangement, cable sizing, connected protection, and the design of the switchboard. After we completing all the calculation, we need to design the DB, SSB, and MSB, which is main switchboard. One of the best distribution system that will supply, educate electrical service the present and a future educate electrical service for the present and future probable loads, cost and efficiency. Problem statement is about an efficient electrical system which is LED to high running costs. Second, contribute hazard to the environment due to the high demand on grid. And third, bad design made the system easily overload. And project objective is the engineering team project aim to design the low voltage electrical installation for administration building. This project is designed to meet the following objective: to analyze and calculate the existing load demand, and to reduce the energy consumption of existing demand, and third, to design the electrical system building and protections. Project scope is about electrical. Project scope is the in a million from the electrical load in the system. This includes by studying the existing load in the electrical building system and propose an efficient building designed by recalculating all existing lamp, illumination and lock to follow the JKR installation standard. The efficiency lighting also include to the design implementing efficient lighting such as LED type of lamp, thus to reduce the lighting demand in a great margin. The SWOT analysis. The strength is option 2. Will design will limit almost 40% to reduce. Option 2 has the highest reducing electrical demand. Weakness is weakness is option to design manage to reduce the lighting load around 10 compared to existing. Weakness is the distribution board design will to be embossed back to for efficiency wiring system, socket and motor distribution board made to the former friendly system. And opportunity is the diffusion board DB of socket and motor can be redesigned, which improve and promote efficiency wiring, cable sizing, and to be evaluated back when DB board is introduced. Third is high total harmonic distortion. Since energy appliances are mainly using direct current, because when we use the LED, we have high harmonic distortions. Thank you.
Okay, for project solution, this is the load assumption that we use on the calculating the load in our design. And this is the diversity factor, and note that we highlight in the we mainly use in the office column here. So for what we do for existing design, actually we evaluate the existing load. We recalculate back each type of load, including the socket and the lamp. And then for the option one, we recalculate back the number of line and wish to comply with the JR standard of illuminance. And then for the option two, we based on the option one, but we propose a new type of lamp, which is the LED lamp. So for the lamp calculation, we will proceed with Chow for his presentation.
Good afternoon to all panelists. My name is Li Zhaoxiang. I'm representing about the lamp calculation. So this is a formula lamp calculation that we apply in our proposal. So this is a quality lamp calculation where is the N is equal to EAV times L times width divided by LDN, divide the coefficient and divide the mounting factor, maintenance factor. So the N is equal to number of the luminance required, and the LDL is the inertial lumens of the each lamp, and the coefficient is the utilization factor, and the MF is the maintenance factor. L is the stand for the length of the room, and well, W is stand for width of the room, and the EAV is stand for the average illuminance required in lux. So for all the illumination of the area of building, we are all calculate according to the standard of JKR for the building illumination. So this is the second formula calculation is a room index calculation. So the K is equal to L times width divided by mounting height times L plus M. So where the HM is equal to the mounting height of the luminance above the working plane, and the L is stand for length of room, and the W is the width of the room. So after we calculate the K, get the K of the K value, we can start to find the coefficient value regarding for the photometric data sheet. So this is one of the calculation example that we had done in our proposal, which is the calculating for the foul room at the level 1. So as you can see, there are some steps to complete the calculation, where the first step is we need to determine the height of luminance above the working plane, which we need to start from to finding the height and the width in the room, which is we need to measure the height and the width in the room. So the second step is we need to determine the room index using the equation previously that I showed to the equation K, and the third step is we need to determine the coefficient of utilization for the coefficient that. But first we need to find the K before we need to get the value of coefficient. So after we find the K factor, you can apply the formula to get the value, which is the K is equal to 1.03. Refer to the table length specification of coefficient. So the last for the find of the average lux is the equal to 300, which is we are following the standard of JKR. So the maintenance factor we are assuming is 0.8, and the assuming lighting design room for the lumen is 5,300, which we are using 2 times fluorescent. So after that we get all the value, we can start to calculate the number of the length, which using the formula from the previous slide, and calculate the parameter. So from the founding room, we get the value of the area is 22.39 meters square. The average lux is 300 that we get from the JKR standard, and the LDL is 5,300 lumen, and the coefficient is 0.8, where the K value is equal to the previous value that we get, and the melting factor is the 0.8. So after we get the value, we need to apply into the n for the equation n. So the total, the number of the length we get is 2.9, where we round it up to 3. So this is a dB length example for the lighting. So as we know that the dB is a main circuit breaker, that is a sub main circuit breaker. It can have a necessary protection for against the safety of equipment and importantly to human. So this is the simple dB design circuit for the lightning system at level 1.
This one, the original one or the one that you propose?
Original.
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 Sorry. Actually, this one is the one we propose because this is the LED type.
Oh,
The one that you propose, okay?
option 2.
Yes.
Okay. Proceed.
So I will pass to Fitri to continue the next.
Okay, thank you, Chow Ziang Lee. Okay, next, my name is Muhammad Azri At-Thani. Okay, today socket is a device provided with female contact, which is intended to be installed with the fixed wiring and intend to receive plug. Okay, switch socket is outlet shutter to pole, a thin pin and a flash type. Okay, the 13 ampere with switch socket outlet and socket outlet of the rectangular pin type. Okay, in this design we have used 13 ampere switch socket. The main advantage of this socket is appliance with loading may be connected with perfect safety to any socket, and under certain condition, an unlimited number of socket may be connected to any one circuit. When overload of the socket will make the fuse blow or cable melting. Okay, there are two types of switch socket, which is radial socket and ring socket. Okay, this is the table of Malaysia practice for 30 ampere socket outlet that available to installation aspect of wiring and cabling. You can see the type of 30 ampere socket outlet. First is a single socket outlet, where the area is 20 meters square and the size of wire is 2.5 millimeters square, and the fuse rating is 16 ampere. And then second is double socket outlet. The area is 20 meters square and size of wire is 2.5 millimeters square, and the rating fuse is 20 ampere. And then the third is a ring. The area is 100 meters square and the size of wire is 2.5 millimeters square, and the rating fuse is 32 ampere. For the ring is the number of socket is over than 6, while for the radial is the maximum number of socket is 6, and the area is 50 meters square, and the size of wire is 4 millimeters square PVC, and the rating fuse is 32 ampere. Okay, this is the example of a calculation we have for the printing room level 1. Okay, we have determined, first we determine the number of socket and the type. Okay, then the quantity of socket in this room is 2, and the type of the socket is a 13 ampere switch socket outlet. Okay, and then we from diversity factor and load estimation. The diversity factor of this socket we use 0.4 for the admin building, and then the estimated load is 250 watt. And to calculate the total connected load, we have to number of socket times we estimated load, where is 2 times with 250 watt, so we can get 500 watt. And then we calculate the maximum demand, the total connected load time with diversity factor. Okay, so we get 200 watt. And then we determine type of wiring to choose breaker and cable size. Okay, the number of socket is 2, so we have used double socket. So it's a radial circuit because it less than 6 circuit. And then the cable size is 2.5 millimeter square. Okay, this is the example of DB socket. Okay, we can see for example this for quantity of socket we use 32 ampere, and for one socket we use 16 ampere, and the two socket we use 20 ampere, so 30 ampere. Okay, that's all. Thank you.
Okay, thank you Fitri for the explanation. So I will proceed with the cable sizing and voltage drop procedure. So for the cable sizing for DB and MSB for procedure, all the calculation for cable sizing are based on the IET installation guide. So the formula is actually IT equal to IX multiplied by 1 over CA multiplied by 1 over CG. If we refer to the IET installation guide, actually the equation will be more, but I just limit to these three because this is the mainly used in our building design. And then the IX also we can choose either IN or IB. IN is a short circuit and overload protection, and the IB is only for short circuit. The difference is if we choose IB, for the IB we will use only the maximum demand current. But if we use IN, the IN will be using the protection rating. If the MCCB breaker is 30 amp, so we will use 30 amp, even though the maximum demand current is only 24 amp.
What is CA and CG? Oh, okay.
So the one for the CA is actually a correction factor for ambient temperature, which you can refer in the page 394 on the IET installation guide. Correction for ambient temperature is actually the regulation, and all cable are designed to only operate at the ambient temp of 30 degrees Celsius. But when we install in our building, maybe we install in a small and confined space, so the ambient temperature of the surrounding will be higher, maybe goes to 40, maybe goes to 50, depending on the building. So since the resistivity of the wiring or the cable will be changed according to the temperature, that's why we'll have the correction factor for ambient temperature. And for the CG is correction factor for grouping. When we want to install within or from the main switchboard to the sub switchboard, maybe we will use a one trunking type. When we use one trunking, maybe there are many cable allocated in the trunking, maybe 4 to 5 cable depending on how many SSB we have. So each cable will contact each other and contribute to some heat and also some magnetization. So that's why we have the correction factor for grouping, which we refer on the page 396 on the IET regulation. So when we use the formula of the IT, we will obtain the IT. When we obtain the IT, we can refer the cable at page 401. At the page 401, there will be a table using the 4D abbreviation. So depending for 4D1A or 4D2A or 4D3A, it's actually depending on the cable type. So this is our calculation for cable sizing example. So okay, from here, this is the IN. IN, like I said before, actually is our protection breaker sizing. And then this is CA. For the CA, we assume the sizing, we assume the temperature will be operate at the 45 degrees Celsius for the ambient temperature. And the CG will be equal to 1 since we using a multi-core cable instead of single core with many cable. So we have many cable, which is one for each phase, one for neutral, and one for earthing. We use one multi-core cable, so it just one cable. So that's why the CG will become one. So by using the formula from the previous slide, we get the IT 160.26 ampere. And actually, there are many reference methods. If I want to cover everything in the slide, it will be longer. So for, for conclusion, the reference method B, actually we using trunking and conduit for our cable layout. So when we see the Isaac here, Isaac actually, when we see the table will have prefix value of the current. So we choose the current nearest and above of our IT, which is 179. And then we will have the cable size of 95 millimeter square. Note that each of our cable sizing will be based on the multi-core cable. Okay, as for the voltage
Can
drop,
I ask again? You mentioned about the trunking and conducting. What do you mean by that one? Is it the sizing of the cable and also the how many of cable in it?
okay, for
The
Jamie
effect of
asking
trunking and
about
conducting.
for
Conduit.
reference method, right? For reference method kan? Okay, for actually trunking and conduit, okay, actually it referring to the CG because when we want to install the wiring, we can't just let the wire bare on the wall or just maybe hanging like that, like a normal transmission line. So we will have a proper enclosure, which is either trunking or conduit. Trunking is basically a metal case which is large enough. Maybe we can see at our PVKSE school. And the conduit is likely a PVC like cable. Not cable, PVC like cylinder pipe, which mostly we can see in our house. Is that okay, Encik Amin?
Proceed. Boleh lah tu.
Okay. Okay, for voltage drop, this JKR requirement standard for voltage drop. When the MSB to SSB is 2%, SSB to DB 1.5%, and DB to our end load is 0.5%. But to cut short, maybe we just calculate for MSB to the end load when we assume it for the 4%. Okay, how the voltage drop is calculated? Note that before on the previous slide, we have the calculation on the cable sizing. Based on the cable sizing, we can determine the voltage drop. And then the voltage drop formula also differentiate into two. The first one is on the top here is for the cable sizing for the 60 millimeter square and below. We will use tabulated MVAM times IB times this the length cos theta over 1000. Cos theta is the power factor for the building, so we assume generally it will have a 0.85. And for the second formula, it actually for the cable conductor above 25 millimeter square and above. So it will be slightly longer formula, which is they have tabulated MV for the Z, R, and then cos theta, and then IB times length over 1000. So where we get this value of tabulated, actually we can get this on the voltage drop meter, which can refer on the table 4D from the page 401. At the page 401, at the table 4D, actually each table will represent each type of cable, and it also represent the voltage drop calculated for the tabulated this calculation. Okay, so this is our example for the voltage drop calculation from SSB to DB. Okay, since if you refer to our layout, actually we placing the SSB to DB all in one place, which is in the electrical row in the middle of the layout, if I'm not mistaken. Okay, so for DB1LN, YN refer to the lighting normal. We'll be using reference method B with the cable sizing of 10. So the current will be 9.25 ampere with the length of 1 meter. We just assume. not that same way because we calculate, but we don't have the precise calculation by not just by referring to the layout. So we are saying it is 1 meter, and the cos theta is 0.85. So the sin theta is 0.53. By referring to the table, when I say that the cable sizing, if it is below, it is 2.5 millimeter, 60 millimeter and below, it will only use one, which is the left one here. So according to the table, the tabulator is 3.8, and the voltage. So when we use the formula, the voltage drop will be 0.04 volt. So if we look for the example 2, the DB1 and F, which is motor normal supply, the cable size is 95 millimeter square. This is because the MD current is 117.57 ampere. So we say the length is 1 with the cos theta of 0.85. So these three actually we refer to the table, and that's why we get these three value, and we calculate using the formula here, where we get the voltage drop is 0.05 volt. Okay, that's all from me. So I will pass the presentation to Abdullah for the load reducing.
Assalamualaikum, I'm Abdullah Muhammad Azri At-Thani. And for load reduction, we got this table that shows the comparison between three designs. The existing design and option 1 design and option 2 design. This table compares the load, the total maximum demand and the total connected load. For existing design, the total connected load is 353.98 kilowatt, and for the total maximum demand, it's 239.71 kilowatt. And for the option 1, the total connected load is 344 kilowatt and 231.72 for the total maximum demand in kilowatt. And for option 2, the total connected load is 321.52 kilowatt and total maximum demand is 213.72 kilowatt. And the total percentage reduction is a comparison between the existing design with option 1, the reduction between it, and the existing design and with option 2 and the reduction between it. So for between existing design and option 2, for the total maximum demand, the reduction, the percentage percentage of the reduction is 3.3%.
Can you say again what's the difference from option number 1, 2, and 3? Option number 1 is existing design from the ETP, right? So option 1, what are you doing? And option 2, what are you doing?
Yeah, I was gonna explain that later, but okay. For option 1, we calculate the quantity of lamps because in existing lamp there's many unnecessary lamps, and there's a large amount of lamps that doesn't follow the JKR rules or standards. So we calculate it back by using the luminex and high and the area of each room. So we calculate back the quantity of each lamp, the quantity of lamp for each room. So, and the same type of lamp for option 1 is the fluorescent lamp, 80 watt and 36 watt. And for option 2, we changed the type of lamp with the same amount of quantity. We changed it to LED, which has 8 watt instead of 18, and 16 watt for 80 watt for 36 watt instead of 36 watt in fluorescent lamp. So we got the reduction for the reduction percentage. For option 1, we got 3.3, and for option 2, we got 10.84%.
Do you find any of different from the option 1 and 2 to the existing design? Compare with the total of lamp or socket and everything.
Between what?
The total of everything. Comparing with the existing design and option 1 and 2.
For existing design, there's a difference in the quantity lamp. between with it and option one. But the type of lamp is the fluorescent for each one, for each option one and the existing lamp. But for option two, we use the calculated quantity of lamps in option one, but we changed the type of lamp to LED for each one, and that's it. We for the percentage, for option two it was 10.84, and we can see from the table that option two is much better. So the LED is much better. And the impact on society and environment for this project. First of all, by replacing the fluorescent lamp with LED. So first thing, for a LED, the advantage is it has a lifetime longer than the fluorescent lamp because of the way it's built and the way it works, and because of the heat temperature on the lamp. Also, for inexpensive LED or cheap LEDs, the lifetime of it is like about 5,000 hours, but which is 4,000 to 3,000 hours more than the incandescent, and also 6 times longer than the fluorescent lamp. And also for the expensive or the good quality of LED, it can be the lifetime of it can be from 25,000 hours to like 60,000 hours. So this is the first advantage, and the second one is the LED efficiency, which transforms the energy to light, not heat. The efficiency of LED is 70% because it doesn't convert it to heat; it converts it to light, which heat in the other type of lamps decrease on the efficiency of it. Which also is the LED has 8 watt and 80 watt, which is less than the other type of lamp. So 70% efficiency and also less water. And for the third advantage of the LED releases electromagnetic energy as electricity by converting energy to light. Rather than heat, LED works with a lower temperature than the other lamps. For the second advantage is reduce of the utility bills. As we can see from the last table, the advantage is that we have a reduction of the total maximum demand by 10%. That's an advantage for our project. That means there's a energy reduction in the consumption. Also, it protects the environment. Energy reduction will minimize the pollution by reducing the energy usage. And that's it for the advantages, and for the project sustainability. The sustainability, what is it? The sustainability is the ability of a project to continue its mission or a program far into the future. All projects have to end eventually, but the project impact should continue. And for the cost of the maintenance, because LED does not need much of maintenance like the fluorescent, because it has first of all it has a lifetime longer than the fluorescent. It doesn't need more components like the fluorescent. And also the cost of it does lower the carbon emissions, as you said, and the protection of the environment. Also, it minimizes the usage of the natural gases for using in houses, because the fluorescent works in gases, but the LED does not have this thing in it. Okay, for the entrepreneur skills that we learned from this project, first of all, as it's obvious, we learned how to reduce the energy consumption in in the administration building or any other building. Like an example for option 2, we designed and managed. We managed to reduce the lighting around 40 efficiency compared to the existing design. And we learned how to reduce the quantity of lamp by using JKR standards and by using the area, the heights of each room, and also to choose the lux and the luminance to calculate the luminance. And also we learned to make a wiring design with a low cost. And that's it.
Okay, that's from us. Thank you. We open for questions.
Abdullah, due to, can you swipe back to sustainability?
Yeah.
What can you tell me how come lowering the carbon emission and minimizing using natural gases using in this housing things, these two factor can affect the usage of your LED lamp? Do you have any reference
Again, sorry,
to your statement?
sorry.
Uh, for point number, lowering the carbon emission and minimizing using natural gases for using in housing, the one that you mentioned previously. Do
Okay.
you have any reference that support these two statements?
Like an explanation.
Yeah, where do you
Okay.
get this statement?
Okay. I read about it on the network, and
Do you have the exact reference?
as we know, the reference. I don't know if I put it in the report.
It's in the report.
No, not in the report. Okay, I didn't put it in the report. Sorry,
Okay. You
but
should,
I can explain it.
because for me it's quite fragile.
Oh,
Quite a fragile statement to say so, because it's just an LED and fluorescent unless you have a very good strong fact that can support these 2 points. Okay. And then I have a question regarding harmonic, the one that Aini presented previously.
Yes.
Where do you get info that LED can cause harmonic for weakness, if I'm not mistaken?
Uh,
Yeah. Something about LED can cause threat, sorry. Threat. High total harmonic distortion.
because when we
Can you explain more regarding this? High total high THD, since client using direct current. Why is
uh,
it so?
this part is Azri have explained to me about this, but I can't remember this.
Doctor can explain it.
Yeah. Sure.
Okay, actually for the total harmonic distortion, from what I learned in the power electronic subject last year,
Mhm.
when we using LED lamp coming from the AC supply, that's why we need a rectifier, right? So there we need a converter,
Mhm.
and depending on the converter and depending on the what we call component of the converter, which is the inductance and the capacitor,
Yeah.
if we use quite a lot of it, it will contribute to the total harmonic distortion in the system, because it's somehow maybe inductive also, even though it's an LED. LED is in the end load, but the converter itself still pose a distortion into the wiring.
So the THD came out from the converter, or
Yeah,
which one is it?
yeah. It actually coming from the converter.
Coming from the converter. So
Yeah.
actually, regardless LED or fluorescent lamp, it doesn't
It doesn't
matter.
clear. The reason why I said mainly using direct current because when we design building, actually each building we also the main supply is in AC. So when we want to use a DC appliance, we must have a converter. So that's why I just straight out use mention it is a direct current instead of the converter. Sorry about that.
Macam tak berguna sikit lah.
Is there
Okay.
any of equipment use the DC other than the LED
Actually,
lamp?
for our current project, we just using on the LED lamp for our design. Just that.
So all the
Baik.
proposed design hanya just only involve LED lamp. You don't anything to change air conditioning system or anything else?
Air conditioning system semua everything using the existing design. We do calculate the air conditioning system, but we don't place here because we don't change it on each option. So we just what we presenting is what we mostly highlight in the system in our project.
For future plan maybe?
For future plan, maybe we can use it. Maybe we using a inverter type air conditioning for more efficient system. So we can see the load demand will be slightly lower than the current day.
Okay, one more regarding something about length slide MCB to DB tadi ada pasal length meter.
Okay. Ni
Cepat
sorry.
Sat.
Oh,
Tadi
ni. Okay.
back one slide.
Okay.
Lagi satu. Okay. If siapa present tadi yang ni?
Saya.
Azri. Okay, kalau tengok yang ni, ini adalah reference JKR. Okay. But your design, you choose based on faktor apa tadi? You calculate based on length kan? Choose your length tu, right?
Yes.
Okay, meaning to say that length as priority in your design. Okay. I
Yes.
just want to ask, kalau dalam building kan dia ada wall, maybe ada panggil apa? Beam kan? So that positioning of wall and beam tu might extend the length of this current design yang you pilih. Don't you think so?
Yes. For that, actually, I do admit because in this, as I mentioned before, because the length I just assume 1 meter. So sepatutnya maybe lebih dan maybe boleh kurang. Cuma saya assume satu sebab saya fikir sebab design saya kat saya punya layout memang saya letak kat satu bilik elek, so maybe just run up and down saja. So tapi bila nak pergi ke end load tu, that will be slight different story. But yeah, maybe some part mistake sepatutnya maybe we can go a bit higher because the end load is still farther from the electrical room, right?
You have the layout of the building, right?
Yes.
So the voltage drop value might be slight different from the current that you've been presenting today, right?
Because we presenting here is actually only from SSB to DB. So for SSB to DB, so the voltage drop maybe still correct, but for DB to the end load, so the value might be different.
Okay. Cik Min, ada soalan?
Dah tanya banyak lah.
Okay.
Dah tanya lah. Okay lah.
Okay, last. Just an open question, siapa-siapa boleh jawab. Existing luminance dengan proposed luminance, kira kan? You calculate right?
Luminance, okay,
Existing berapa, lepas tu you dah tukar dengan LED, you ada calculate tak berapa proposed luminance?
Luminance. Oh, lampu
LED ha. Adakah sama dengan existing? Atau dia lebih gelap?
LDR tu kan, like lumen tu kan.
Hmm.
Kita ada orang pakai hotspot. Easy, aku tengah bising. Easy. Hello, clear?
Okay.
Okay, sorry interruption. Okay, yang doktor tanya tu, yang bahagian ni kan.
Sebab so far yang saya tengok yang being calculated adalah reduction power, betul?
Betul.
Okay, so saya hanya nak verify adakah dengan reduction power ni mengurangkan luminance yang sedia ada ataupun you boleh improve lagi?
Dia tak kurangkan pun sebab kami choose ada yang ni kot. Macam ni yang 16 watt ni. Okay, sebab kami choose lampu ni untuk sebatang lampu ialah 2500 lumen. Jadi untuk dua batang lampu ialah 5000 lumen. Which is bila untuk fluorescent lamp, untuk batang lampu ialah 2250. Dan saya lupa saya letak calculation dekat mana, tapi sepatutnya bila saya dah run untuk luminance calculation untuk lampu tu, bila kami pakai lampu yang baru ni, dia tak ubah value pun, just ubah point something saja.
Okay, which is good lah.
Which is good, still acceptable. Sebab tu kami just tukar je, sebab ni memang universal, just swap lah.
Alright. Benda tu boleh masuk dalam report lah as your adding point.
Yeah.
Okay, I'm done. Amin, you nak tanya apa-apa ke?
Okay, from my side also done. Do you have any question?
Okay guys, thank you very much for your presentation.
Okay.
Thank you, Dr. Encik Alamin tadi.
Thank you, Dr. Encik Amin.
Okay.
All the best for your future test.
Thank you, Dr.
Our presentation session.
Okay.
Ada berapa soalan nak tanya panel?
Dia ETP 2 ada lagi kan, Doktor?
Inilah ETP 2 kan?
Bukan. Sebab ada dengar yang apa ETP 2 tak ada. Saya dengar je lah tu yang saya tanya.
Ada. Still ada.
Oh ada okey. Sebab ingat nak improve lagi. Okey.
So dalam ETP 2 tu kita kena buat benda yang benar ke atau macam masih dalam calculation and simulation saja?
I'm not sure. Kena tanya your coordinator. Sebab yang if I'm not mistaken, I'm hoping to see that you tackle not more than just changing the LED lamp. There's some maybe you patut letak new inverter air conditioning system maybe, tapi benda tu tak berlaku. Student saya pun tak ada. So I don't know whether benda tu mungkin you implement for ETP2 ataupun there's another method yang akan Encik Hasnizam propose untuk ETP2 lah. So just wait for the punya command lah.
Okay.
Okay. Okay guys, thank you for your time.
Thank you.
Selamat berpuasa dan selamat Hari Raya.
Hari Raya. Terima kasih. Assalamualaikum.
Waalaikumsalam.
Assalamualaikum.